Good day, this is the Professor, CBMD PhD, and today's Saturday, March 25th, 2023. It is 5:38 and 11 seconds, a.m. Eastern Standard Time, and today's research, Y-ball. So let's jump to it here. Y-ball compound yields quantum secrets. Physicists provide theoretical insights on experiments involving a strange metal that could be foundational to next generation quantum technologies. Date March 21st, 2023. Source: Rutgers University. It is likely that quantum materials will drive the next generation of technology, and that strange metals will be part of that story. We know that strange metals like Y-ball exhibit properties that need to be understood to develop these future applications. We are pretty sure that understanding this strange metal will give us new ideas and will help us design and discover new materials. Researchers describe details of electronic motion that provide new insight into the unusual electrical properties of Y-ball, the material technically known as a compound YBA, IB sub 4, contains the elements ytterbium, aluminium, and boron. The experiment revealed unusual fluctuations in the strange metal's electrical charge. The work is groundbreaking, the researchers said, because of the novel way the experimenters examined Y-ball, firing gamma rays at it using a synchrotron, a type of particle accelerator. Researchers have spent years exploring the mysteries of strange metals. They do so through the framework of quantum mechanics, the physical laws governing the realm of the ultra-small, home of the building blocks of nature, such as electrons. Analyzing the material using a technique known as Mossbar spectroscopy, the scientists probe Y-ball with gamma rays, measuring the rate at which the strange metal's electrical charge fluctuates. In a conventional metal, as they move, electrons hop in and out of the atoms, causing the electrical charge to fluctuate without a rate that is thousands of times too fast to be seen by Mossbar spectroscopy. In this case, the change happened in a nanosecond, a billionth of a second. In the quantum world, a nanosecond is an eternity. For a long time, we have been wondering why these fluctuations are actually so slow. We reason, continued conjure, that each time an electron hops into an ytterbium atom, it stays there long enough to attract the surrounding atoms, causing them to move in and out. This synchronized dance of the electrons and atoms slows the whole process so that it can be seen by the Mossbar. Researchers explain that when an electrical current flows through conventional metals, such as copper, random atomic motion scatters the electron, causing friction, called resistance. As the temperature is raised, the resistance increases in a complex fashion, and at some point it reaches a plateau. In strange metals, such as Y-ball, however, resistance increases linearly with temperature, a much simpler behavior. In addition, further contributing to their strangeness, when Y-ball and other strange metals are cooled to low temperatures, they often become superconductors, exhibiting no resistance at all. The materials with the highest superconducting temperatures fall into the strange family. These metals are thus very important because they provide the canvas for new forms of electronic matter, especially exotic and high temperature superconductivity. As superconducting materials are expected to be central to the next generation of quantum technologies because, in eliminating all electrical resistance, they allow an electric current to flow in quantum mechanically synchronized fashion. The researchers see their work as opening a door to future, perhaps unimaginable, possibilities. In the 19th century, when people were trying to figure out electricity and magnetism, they couldn't have imagined the next century, which was entirely driven by that understanding. And so, it is also true today that when we use the vague phrase quantum materials, we can't really envisage how it will transform the lives of our grandchildren. And this is the Professor of Advanced Mathematics, Space Technology, and Computer Science, and this video was created for educational purposes only. Hope you enjoyed listening. Until next time, have a great day.